In just a few seconds, nature can reshape the world. From the skies above to the oceans below, Earth's fury is breathtaking and terrifying. Volcanoes erupt, spewing molten rock and ash. Tsunamis surge, swallowing coastlines with relentless force. Tornadoes rip across the land, leaving a trail of destruction in their wake. But what causes these unstoppable forces? Join me as we explore the awe-inspiring power of nature. Imagine standing on a beach, the sun warm on your skin, the gentle lull of the waves a soothing rhythm, but far out at sea, hidden from view, a force is gathering. A force triggered by the very ground beneath the ocean, shifting, groaning, unleashing its pent-up energy in a cataclysmic upheaval. This is the birth of a tsunami. Tsunamis can travel at the speed of a jet plane, their energy compressed beneath the surface, invisible to an unsuspecting world. They can cross entire oceans, their power undiminished until they finally encounter land. And when they do, they rise up, a towering wall of water, crashing down with unimaginable force. In 2011, the coast of Japan bore witness to this terrifying spectacle. An earthquake, deep beneath the ocean floor, unleashed a tsunami that reached heights of over 130 feet. The wave, relentless in its advance, swept inland for miles, engulfing homes, businesses, entire communities. The Tohoku tsunami, as it came to be known, served as a stark reminder of the devastating power these waves possess. Early warning systems, put in place after previous disasters, blared their warnings, giving some coastal communities precious minutes to seek higher ground. Deep within the Earth's crust, hidden beneath serene landscapes, lie slumbering giants. These are the supervolcanoes, capable of eruptions that dwarf any volcanic event in recorded history. Their power lies dormant for millennia, building slowly, inexorably, until the Earth can no longer contain their fury. Unlike their smaller, more frequently erupting cousins, supervolcanoes do not announce their presence with towering cones. Instead, they lie hidden within vast depressions called calderas, remnants of their previous cataclysmic eruptions. Yellowstone National Park, a landscape sculpted by geysers, hot springs, and breathtaking beauty, sits atop one such caldera. The last supervolcanic eruption occurred approximately 74,000 years ago in Indonesia. The eruption of the Toba supervolcano ejected an estimated 2,800 cubic kilometers of material into the atmosphere, plunging the Earth into a volcanic winter that lasted for years. The impact on life on Earth was profound, leading to widespread extinctions and shaping the course of human evolution. But while the threat is real, it is important to remember that supervolcanic eruptions are incredibly rare. Scientists estimate that a supervolcanic eruption occurs on average only once every 100,000 years. Advances in volcanology are providing us with the tools to monitor these sleeping giants, to detect the subtle signs of unrest that may precede an eruption. By studying the geological record, analyzing gas emissions, and tracking ground deformation, we are gaining a deeper understanding of the processes that govern these powerful forces. The air grows still, heavy with humidity. Dark clouds gather overhead, blotting out the sun, casting an eerie pall over the landscape. Then, with a roar that seems to shake the very ground, a tornado descends from the churning heavens, a vortex of wind and debris, its funnel a dark scar against the storm-tossed sky. Tornadoes, nature's spinning dancers of destruction, are born from a unique confluence of atmospheric conditions. Warm, moist air collides with cooler, drier air, creating an unstable environment ripe for powerful updrafts. As these updrafts intensify, they can begin to rotate, forming a swirling column of air that stretches from the storm clouds to the ground. The power of a tornado is often measured on the enhanced Fujita scale, ranging from EF0 with winds up to 85 miles per hour to EF5 with winds exceeding 200 miles per hour. These monstrous storms can level entire neighborhoods in seconds. Their whirling winds ripping apart buildings, uprooting trees, and tossing cars through the air like toys. In the United States, known as Tornado Alley, a region stretching from Texas to South Dakota, experiences the highest frequency of tornadoes in the world. Meteorologists use sophisticated radar systems, weather balloons, and computer models to track the development of thunderstorms and to issue timely warnings when conditions are favorable for tornado formation. These warnings, broadcast through various media, give people in the path of a tornado precious minutes to seek shelter and protect themselves. We walk upon the earth, seemingly solid and unyielding beneath our feet. Yet hidden beneath the surface, a constant dance of forces is at play, shaping and reshaping our planet. The Earth's tectonic plates, vast slabs of rock that make up the planet's outer shell, are in perpetual motion, grinding against each other, pulling apart or colliding with unimaginable force. It is at the boundaries of these plates where most earthquakes occur. As the plates move, stress builds up along their edges like a spring being compressed. Eventually the stress becomes too great, the rock fractures, and energy is released in the form of seismic waves that radiate outward from the point of rupture. These waves, traveling at speeds of up to several miles per second, cause the ground to shake, sometimes violently, for seconds or even minutes. The intensity of an earthquake is measured on the Richter scale, a logarithmic scale where each whole number increase represents a tenfold increase in the amplitude of the seismic waves. Earthquakes can strike without warning, leveling cities, triggering tsunamis, and forever altering landscapes. The 1906 San Francisco earthquake, with an estimated magnitude of 7.9, remains one of the most significant earthquakes in U.S. history. The earthquake and subsequent fires devastated the city, claiming over 3,000 lives and leaving hundreds of thousands homeless. Scientists and engineers have made significant strides in understanding these seismic events and in developing technologies to mitigate their impact. Early warning systems, while still under development, hold the promise of providing seconds or even minutes of advance notice before the strongest shaking from an earthquake arrives. A single spark, a bolt of lightning, a carelessly discarded cigarette in the tinder-dry conditions of a drought-stricken forest. It takes but a small ignition source to unleash a conflagration. Wildfires, a natural part of many ecosystems, can quickly escalate into raging infernos, consuming everything in their path. Fueled by dry vegetation, wind, and topography, wildfires can spread at alarming speeds, creating their own weather patterns, with towering columns of smoke and embers carried aloft to ignite new fires miles away. While some wildfires are started by natural causes, such as lightning strikes, the majority are ignited by human activity. Climate change, with its rising temperatures and increasingly frequent droughts, is exacerbating the problem, creating ideal conditions for wildfires to ignite and spread. The consequences of these raging infernos are far-reaching. Homes and communities are reduced to ash, wildlife populations are decimated, and vast tracts of forest, vital carbon sinks that help regulate our climate, are released back into the atmosphere, further contributing to global warming. Firefighters, working tirelessly on the front lines, risk their lives to contain and extinguish these blazes, employing a combination of traditional firefighting techniques and cutting-edge technology. Scientists and forest managers are also working to develop new strategies for preventing and managing wildfires, including prescribed burns, which involve intentionally setting controlled fires to reduce the amount of flammable material in forests. Over warm ocean waters, a storm gathers strength, drawing energy from the heat below. Winds swirl faster, clouds spiral inwards, and a monstrous cyclone is born, a rotating tempest with a calm eye at its center, a deceptive tranquility amidst the surrounding fury. Hurricanes, typhoons, and cyclones, different names for the same meteorological phenomenon, are all fueled by the same powerful force-warm ocean water. As warm, moist air rises and cools, it condenses, releasing heat and creating an area of low pressure. This low pressure draws in more air, creating a cycle of rising air and condensation that fuels the storm's growth. These swirling behemoths can grow to hundreds of miles in diameter, with sustained wind speeds exceeding 150 miles per hour. They bring with them a triple threat of destruction: high winds, torrential rainfall, and storm surge. A rise in sea level caused by the storm's powerful winds pushing water towards the shore. The impact of a major hurricane or cyclone can be devastating, flooding coastal communities, ripping apart buildings, and leaving behind a trail of destruction that can take years to rebuild. Meteorologists, using satellites, radar, and computer models, track these storms from their formation, providing advance warnings to communities in their path. Coastal communities have also developed sophisticated evacuation plans, learning from the lessons of past storms. From the fury of a volcanic eruption to the relentless power of a tsunami, we have witnessed the awe-inspiring and sometimes terrifying forces that shape our planet. But amidst the destruction, a question arises. Can we predict or even prevent these natural disasters? The answer, as with many things in nature, is complex. We cannot, at least not yet, prevent earthquakes from shaking the ground, nor can we halt the advance of a wildfire or steer a hurricane away from land. These forces are driven by processes far beyond our control, by the very dynamics of our planet. However, while we may not be able to control these forces, we are not powerless in their wake. Science has provided us with the tools to understand these events, to predict their occurrence with increasing accuracy, and to develop strategies to mitigate their impact. Seismographs allow us to monitor the Earth's movements, detecting the subtle tremors that may precede a major earthquake. Sophisticated computer models fed by real-time data from weather satellites and buoys track the development of hurricanes, predicting their path and intensity, living in harmony with Earth's power. The Earth is not a static, unchanging backdrop to our lives. It is a dynamic, living planet, constantly evolving, reshaping itself, reminding us of its power and our place within its grand design. Nature is both creator and destroyer. Its power reminds us of our place on this planet, not as masters but as stewards. We are but one species among many, sharing this planet and its resources, subject to the same forces that have shaped life on Earth for millennia. Let's learn from the past, prepare for the future, and never forget the awe of Earth's power. By respecting the power of nature, by studying its intricacies, and by working together to mitigate the risks posed by natural disasters, we can create a future where humanity and nature coexist in a delicate balance. If you were amazed, hit like, share with a friend, and subscribe for more earth-shaking wonders every week.